So this is about analyzing tennis serve performing with game theory, and this study focuses on improving the analysis of technical and tactical performance in competitive tennis, addressing limitations in current approaches. Early research relied on descriptive statistics uh, for first serve percentage, winners, unforced errors, and analytics models like neural networks and stochastic predictions to examine performance. However, these models fail to sufficiently explain athletes' decision-making processes during matches, which involve dynamic interaction and strategies. To overcome these limitations, game theory has been adopted particularly to explore strategic decisions and Nash equilibria in tennis. Prior studies used points as the unit of analysis, but oversimplified the intricate details of strokes and their contributions to rally outcomes. Additionally, assumptions about mixed strategy Nash equilibria often overlooked practical constraints like serve state dynamics, court positioning, and board trajectory. trajectory. This study introduces the stroke performance relevance (SPR) metric, rooted in pure strategy Nash equilibrium assumption to address these gaps. The SPR metrics evaluates the impact of each stroke on rally outcomes using detailed stroke level data from men's singles matches at Wimbledon, where the serve is tactically significant on grass courts. By quantifying the tactical value of different serve placements, the study identifies optimal strategies for maximizing competitive advantage. The work progresses through first, it's formulating the SPR index for individual strokes. The second is constructing a game matrix based on serve strategies and applying the SPR index. And the third is analyzing the pure strategy Nash equilibria with a focus on tactical outcomes. The study concluded by highlighting the advantages of SPR metric, discussing its implications for strategic decision-making, and emphasizing the importance of Nash equilibria in shaping tennis strategies. This approach offers deeper insights into athletes' performance and in decision-making progresses, with potential application in competitive analysis and tailored training. So this is about how the author describes each variations. So first of all, that L denote the total number of sets, its sequence number of each set in the match, and PPR, the relevance ratio, PR of set I in a match, which is represented by here, and M denote the total number of games in set L. So its code is presented here, and the third is presented here, and the fourth is presented here, and the fifth is presented here, and the sixth and seven are here. So the summary of this part is to describe the mathematical approach to quantify the relevance of each stroke in tennis rallies using the SPR metric. The process involves several steps to calculate performance relevance ratio. So it is about set level here. It is about the game level and the point level and the stroke level. So the overall SPR for a stroke is derived by multiplying here. Where is my mouse? Wait, it's here. The overall SPR for a stroke is derived by multiplying the PRRs at all levels set game point stroke. This method enables a detailed assessment of each stroke's contribution to the rally outcomes, offering a granular and temporally sensitive understanding of tennis tactics. And this is the game matrix model. Table 1, Table 2, and the player 1 have three options: inside, outside, middle, and player B have two: forehand and backhand. And the table 2 is another is is about the matrix model. So again, so player A chooses strategy A1, table 2. Alpha represents the maximum payoff of player A in the optimal strategy set, and beta denotes the maximum payoff of player B in the optimal strategy set. The calculation formula is as follows here. And if alpha beta belongs to AI, includes A 1 to 3, then S star is a pure strategy Nash equilibrium. So this part explains how pure strategy Nash equilibria are calculated in the context of a tennis match. It it defines the conditions under which a pure strategy Nash equilibrium is achieved, focusing on the serve and receive strategies. Um, So S star is a Nash equilibrium if no player can benefit by changing their strategy while the other player's strategy remain unchanged. Mathematically, this is presented by UI bigger equals than UI, where UI is the utility of player I. And it denotes player 1 have 3 strategy sets, and player 2 receive 2 strategies. So this methodology enables the identification of equilibrium strategies, providing insights into optimal decision making during tennis matches, particularly in serve and receive dynamics. So this model quantifies the impact of each stroke in a rally on the match outcome, considering the sequence of actions taken by both players. It's not like a traditional method that focus on points. So this model analyzes strokes, providing a more detailed understanding of the serve influence. So the SPR models consider PR of each stroke, and the ratio is calculated based on the stage of each match. And so the the game compares general surface statistics from 40 matches, 155 sets, and 1069 1696 games. So player A has significantly higher success rates in key metrics such as in first serve won, and the second serve won compared to player B. Metrics like the number of aces and double faults showed no significant differences. Um, Service um, placements data was analyzed across three zones: inside, middle, outside, and the two surface area left and right, which is here. Across the three zones, are have no there are no significant difference found between winners and losers for most placements, except for the left side outside placement, where player A performs significantly better than player B. And the SPR index was calculated for various surface placements. Player A consistently showed a higher SPR index for critical placement, particularly for first serve on the right side outside placement and the second serves on the left side inside and middle placements. The game matrix model was constructed for each player's serve scenarios, 8 in total, covering first and second serves in both and left areas. Across 40 matches, player A exhibited fewer scenarios where zero pure strategy Nash equilibria, but more with two strategy Nash equilibria than player B. This highlights the effectiveness of player A's serve tactics in maximizing competitive advantage. The comparison of SPR um, the comparison of the SPR model indices for poor Nash strategy equilibrium shows significant differences. Matches with two strategy equilibria had higher SPR indices than those with one strategy equilibria. Zero strategy equilibria were rare and observed only in players A serves, and the comparison of SPR for different pure strategy Nash equilibrium matrix model tells us that player A exhibited significantly higher SPR indices across all strategy matrix models compared to player B. The two strategy equilibrium models show the largest SPR advantage, underscoring the strategic importance in influencing match outcomes. And the comparison of SPR with other analytics model is about existing tennis analysis methods often assume equal importance of all points, neglecting the cumulative impact of strokes. The SPR method incorporates temporal progression and provides a more realistic reflection of performance by assigning greater relevance to strokes closer to the end of matches. So this study found out there uh, there is a higher SPR index than those with one only Nash with only one or zero Nash equilibria. This suggests that predictable serve tactics can be highly effective in achieving a better outcomes. So winning players exhibited 119 game matrix models with two pure Nash strategy equilibria, and losing players show 135 games matrix models with two pure strategy Nash equilibria. So let's talk about the outcome. So the analysis from this paper demonstrates the multi-phased role of serve performance in competitive tennis. This study revealed a strong correlation between the SPR index and match outcomes. And it is about winning players consistently displayed a higher SPR index for their serves, particularly in scenarios with two per strategy Nash equilibria. And losing players generally had lower SPR index, indicating that their strategic choice might have less effective in maximizing their performance. The analysis from this paper demonstrate the general indicators, service placements, and the application of game theory. The study highlights the tactical superiority of winners in key areas. The use of the SPR metric in Nash equilibria provides valuable insights into the strategic dynamics of tennis serve. offering practical implications for athletes and coaches seeking to refine their approach to serve tactics. This comprehensive analysis underscores the importance of adaptability, precision, and strategy in achieving success on the court. This research highlights the significance of analyzing tennis serve performance using game theory and the model. So, future research can explore the influence of other factors, such as court surface, gender, and different stages of the game, to gain a more comprehensive understanding of the SPR model and its application.